Hi everybody and welcome back to another video from Geoscience Skills channel. When we work on determining cutoff value for a certain property, we need to consider the heterogeneity of the reservoir. In the world, there are many examples for heterogeneous reservoirs, such as shale sandstone or non-clean sandstone, thin-bedded sandstone, alternated with shale intervals, highly diagenetic carbonate reservoir, fractured reservoirs, and chalk reservoirs, and many more. So, as a geologist, while you are working on heterogeneous reservoir, you may need to create different scenarios of cutoff for every reservoir property. Why is that? To test the parameter cutoff sensitivity and impact on the volumetrics of the reservoir. So today, in this exercise, I will show you how to produce multiple lithology cutoff logs for a classic heterogeneous reservoir using Petrel Workflow. Workflow in Petrel is very flexible process and time saving. It enables generating a lot of data using different scenarios in a very short time. So let's start the exercise. This is the Petrel project that we will use to do lithology cutoff exercise. Before doing anything, we need to make sure that we have the data to be used for cutoff calculation, which is the gamma ray available under global well logs. We need also to make sure that this log is available for each well. So we check each well data to confirm the presence of the gamma ray log. Now after that, we move to the workflow tab and right click on the space and create a new workflow. Here we put the name for the workflow and let's call it for this exercise Cutoff Workflow WF. And here will be the name inserted automatically for the person who designed this workflow, and the date in which the workflow was made. In this tab here, we have all the processes, functions, and utilities to design the workflow for different purposes. However, we will use some of them to build up the workflow for this exercise. At the beginning, we will need to define three variable functions as follows. The first variable is the cutoff, and we need to define it in a numeric expression. So we go to numeric, we look for numeric expression, and we drag it to the workflow. We put the name cutoff, and here we write the cutoff value, which is initially will be 30. So it will be 30 API of gamma ray. So as a reminder, API is the measurement unit of the gamma ray. Second variable is the increment, which will be defined in another numeric expression. So we drag another numeric expression below line 1 and we write increment, and we put the increment value 5. The increment value is the value by which cutoff will increase or decrease. In the next line, we put another numeric expression, but this time we define the number of runs. This time we define the number of runs that Petrel should apply. So we type runs and make it this time 10 runs. This indicates how many times Petrel should process the cutoff calculations with certain increment value adding at the time. The number of the output cutoff discrete logs will be based on this number. So to clarify this, let us say that I put the number of run as 10 and the increment value as 5. And when I run, I will get 10 cutoff logs with increment value for each one. In another scenario, if I put the number of runs as 5, this means that 5 discrete cutoff logs will be generated. Now we come to the input data. We will set a reference which refers to the data that Petrel will use to calculate cutoff. In this exercise, it will be gamma ray log. So we add a function called setReference. We can type it in the search box here and press enter, and we can find it under variables. We drag it and we drop it under the last line. It's important to note that Petrel recognizes the input and output data as variables. So this is why we need to assign a variable for gamma ray log. So we set it, we set here a variable C that we can find under variables in the workflow tab. So we choose variable C and we drag it here. So this variable C refers to the input gamma ray log. Here we add the input data, which is the gamma ray log. We need to make sure that we add it from under global well logs, not from the individual wells. It's also important to make sure that all the wells have the gamma ray with the same name and the same template. Otherwise, the workflow will not work properly. Next, we have to assign output folder. Make output folder for the cutoff logs that will be generated with a name and location. It's the folder I want from Petrel to save the produced cutoff log scenarios inside. So we look for new folder here. We go back to the search box and drag and drop a new folder under the last line. As I mentioned, since we will use gamma ray log, which is the available for all wells, we will make the output data folder under global well logs. So I go and drag global well logs to this space here. Here we write the name of the folder under which cutoff logs will be stored, and let us name it all cutoff runs. And here, as we said earlier about assigning variables for each data that Petrel processes, we assign a variable for the output folder, all cutoff runs, and we assign it as variable A. Next, we come to the most important and most interesting function in the workflow, which is the loop. To define loop, it's a sequence of instructions that is continually repeated until a certain condition is reached. Loop is a well-known function and represents an essential component in any programming language. To understand the meaning of loop, let us make an illustrative example. Elevators in buildings. Let's assume that we have a cartoon for building and we have several floors. The elevators in the building start their journey from the ground level. So when they start going from the ground level up to the top, they start the first loop. And when they reach the top, they go back down again to finish or end the loop. Then they go up again and come back again in another loop, and so on. So they start from the ground level, the loop is open. When they go back to the ground level, they end or close the loop. Going back to our workflow before we input the loop, I will illustrate how the loop process work in this exercise in Petrel. You remember earlier at the beginning, we defined three variables: the cutoff value, the cutoff variable, the increment, and the number of runs. We intend to make a number of runs for cutoff calculations, right? So Petrel will run cutoff calculations 10 times as we specified here, and every time it will add the increment of 5 as we wrote here. What Petrel will do is to use a calculator to generate cutoff discrete logs. The first run, Petrel will generate a cutoff log for the initial value, which is 30 API of gamma ray log, which means that below this value there will be a clean sand and above will be shale or shaly sand or dirty sand or whatever. Next, Petrel will, after generating the log, Petrel will store the output log, which is this one, under the folder, the output folder that we defined as all cutoff runs, and save it under global well logs. The name of the cutoff log will be defined later in the calculator. By the end of the first run, the first loop is closed, and Petrel will then move to the next run, which is another loop, starting again with the calculator to generate a second cutoff log. But this time it will add an increment of 5 to 30 to previous or the initial cutoff value 30. This means that it will calculate 30 plus the increment 5, it equals 35. The log produced from the second run will be saved under the name will be saved under same cutoff folder in the global well log, and like this another loop is closed. After that, Petrel will go back to the calculator and do the third run. The third run, it will add 5 to 35 in that was generated in the second run. So we will have a cutoff value of 40. And Petrel will keep running and adding the increment value until it finishes the run to number 10, which is the maximum or the last run that we ask Petrel to do. So once Petrel creates the last cutoff log, it will end the final loop and move to the next step on the workflow. Now let's go back to Petrel workflow and start inserting loop functions to generate lithology cutoff logs. So we look for loop, and we go to for loop, select it and drag it. Keep in the variable the $sign as it is. Here we put the number of runs, so we tell Petrel to start from 1 up to the last number we specified, which is 10. But be careful, do not put the number. You need to put the code or the reference of the last run, which is 10, and this time it's the $sign runs. So copy it and put it here. After that, we insert the calculator that will do the calculation. So we search for calculator here. First, we need to get name for the calculator. We need to define it first. So we get calculator name and drag it, put it below for loop, between for loop and end loop. We assign name for the calculator. Let's call it log gr, and we assign a variable for the calculator, and it will be the same variable that we assigned for the input data, which is the gamma ray log earlier, which is the variable C. Drag it and drop it here. After that, now we can insert the calculator. Since we are using gamma ray log, which is a wireline logs, we will insert well log calculator. So I put here well log and look for the calculator. This is the well log calculator, so I drag it and drop it here. In this space, I will drag and drop the wells folder. Since we are working on a file available inside global well log, which is the gamma ray, and the folder that we created to store the cutoff logs produced from the process will be also stored under global well logs, Then we will drag and drop the will folder which contain all, and we put it here. Later, when we write the equation inside the calculator, the expression or the equation will be highlighted in this space, or will be written in this space. So let's open the calculator to write the equation. And before we write the equation, we need to work on some settings. The first one is attach the new to the template. Since we are doing a lithology cutoff, we will attach the output cutoff log to lithology template. So let's look for it. Yes, this one, and we choose it. Next, sample MD, we choose the same log, which is the gamma ray log. Now we come to the equation. Now I will write the name of the output cutoff file, which will be lithology underscore f underscore cut off underscore is underscore, and this time I will write the numerical expression of the cutoff value, which is 30. I choose from here, from the first numeric expression, copy it and go back to the calculator and paste it and write equal. Why do I write it in this way? So that each log generated, it will add the value of the cutoff with the increment value that was added to the initial cutoff value. We will see in the output folder later. We will display the results later to understand why do we write the name in this way. So after if, we use if condition. Okay, now what I'm telling Petrel is that if the gamma ray log, but this time I will take the variable, okay, the variable which refers to the gamma ray log, which is this time the name of the calculator. So I copy the name of the calculator which refers to the gamma ray log input and paste it in the equation. So if the gamma ray log, okay, is less than 30, if it's less than 30, this means that it's clean sand, to give it a simple 0 or make it 1 as shale or dirty sand or shaly sand as 1. Then I hit enter, and now the equation has been displayed here in the expression space. Next, we work on the output folder that will contain the produced cutoff log. So we bring a function called for all icons. Bring it and drop it here. In this space, we will drag and drop global will logs, which contain all cutoff runs folder that we specified in function 5 and for which we assigned variable A. In this function, we will tell Petrel to put the output files, which is the scenarios or the number of cutoff logs, to be stored inside global will logs inside the all cutoff runs folder. And here we assign another variable for the output cutoff logs, and we make it variable B. Next, saving the output log is not done yet. We have to make a code or function asking Petrel to move the cutoff log that will be generated from the calculator into the all cutoff runs under global will logs. So we choose a function called move. This one, drag it and drop it. Here we specify the object we want to move, which is the generated cutoff log that was assigned as variable B. So I bring variable B. Now what I want Petrel to move this object into the object which is the folder in which the generated cutoff logs will be stored inside it, that we refer to as variable A. So I drag variable and drop the variable A here. Now, before we close the loop, we must add an important function, the one by which Petrel will add the increment value to the initial cutoff log at each run. So I go to numeric expression again, choose numeric expression and bring it below the end loop. I will put in this space the expression or the code of the cutoff I selected from here and paste it here. So what I tell Petrel? I tell Petrel that this value you have to calculate it or add it to the increment value which is available in the second numeric expression here. So we have the $sign cutoff plus the $sign increment, which refers to the number of increment. So each time Petrel at each run will do the calculation of this value of the cutoff to the increment value as we explained in the slide of the loop explanation. After that, we end the loop, which represent the end of the workflow. We can, if we want, we can add save. After this numeric expression, the loop will end. So we can recap quickly. We can recap the workflow quickly. So at the beginning, we defined the three variables: the cutoff value, the initial cutoff value, the increment value that will be added to the initial cutoff in each of the 10 runs. Then we defined the input log, which is the gamma ray, and the output folder. We named the output folder and we set a variable to it. Then we opened a loop, okay, in which we define the calculator name and the calculator equation, how it will be done. There's a note, there's an important notes. I should have done it earlier. It's wrong to put the initial cutoff 30 as number. We need in the calculator, we need to put the expression, the numeric expression. Otherwise, Petrel will not work properly and will not generate cutoff logs. So what we need to do is that we go back to the calculator, click on the calculator, and we copy the expression of the cutoff value. Sorry. And place it here instead of 30. And we hit enter. Now 30 changed to the numeric expression of the cutoff. Then we go to hit apply, test our workflow to make sure it's okay. Then we hit run. Okay, Petrel here tells us that there is a problem with line 8. Line 10. So we stop the workflow. Okay, so when we stopped the workflow, we can see that Petrel generated the lithology cutoff based on the initial value, which is 30. So when we click, we can see that the log has been generated after we stopped the workflow. So why the workflow showed us the early message? Because there's no problem with the line 10, which tells that to move the object, which is the output cutoff lithology cutoff log, into the specified folder. But actually, the problem is that Petrel could not find the log based on which it will add the increment each time in each run. So what we need to do now is little tricks. We need to drag the initial lithology cutoff value based on 30 value. We drag it and drop it here in line 9. And then we click apply, test, and hit run again. And we can see that the results has been generated under all cutoff runs under global well logs. Now let's close the workflow and display our results. So we have 10 cutoff scenarios has been generated through 10 runs processed by Petrel in the workflow. Reservoir heterogeneity raises a lot of challenges, not only with cutoff selection and reliability. It also has an impact on the rock typing methodology, also impact on the dynamic behavior of the reservoir fluids and production at field scale. In addition to well scale, it also raises a suspicion in the quality of borehole logging data and analysis, such as resistivity logs analysis. So, as a geologist, in such situations, you need to apply different scenarios of cutoff to reduce reservoir property uncertainty, impact on the volume. That's it for now. And before I end up, I would like to draw your attention that I have recorded 2 more videos about the same subject of cutoff. One is about the cutoff meaning, definition, and the types of the net pays. The other one is about cutoff application. You can find the links to these 2 videos in the description box below. So thank you for your time and your knowledge-seeking quest through my channel. And until I see you in more and more videos from Geoscience Skills channel, inshallah, UKOL. Keep on learning. Geoscience Skills. Thank you for keeping learning.